Hello everyone, welcome back to my channel. My name is Manny, and today I will be dropping dynamics video number 2. In this video, I'll show you how the kinematics of a particle applies to throwing a ball. We'll look at the motion of the ball after it leaves my hand and how we can use kinematic equations to predict how far it travels and how long it stays in the air. So pretty much, I'm going to be throwing a ball with some initial speed, which we could call V initial, at an angle above the horizontal. So it's going to be heading this way. Once the football leaves my hand, we'll model it as a particle and ignore spin and air resistance. Gravity will be the only force acting on it, giving it a constant downward acceleration, which we'll call A. And the problem we want to solve is how long is the ball in the air, and also how high does it go. From this video, we are not able to break down the ball's initial velocity into two components. Right here, I got this green arrow representing the initial velocity, which forms an angle theta above the x-axis. This pink parabola represents the ball's path, with x being its highest point, where velocity is now equal to 0. From this, we are able to use trig to determine its vertical components in the x and in the y. V initial in the x direction is equal to V initial times cosine theta, and V initial in the y direction is equal to V initial times sine theta. Lastly, we can use the vertical motion equations for velocity and position in order to solve for the maximum height, total flight time, and the time taken to reach maximum height. This first equation here describes the vertical velocity of the football at any time. We see here that gravity reduces the upward velocity until it becomes 0 at the top. We can use this equation to solve for the time needed to reach maximum height by setting Vy equal to 0 and then solving for t. This equation right here describes the vertical position or height of the football. We can use it to solve maximum height by plugging in t from this equation when vertical velocity is equal to 0. We could also use it to find the total flight time by setting y equal to 0.